Hi, good day, everyone. Thank you so much for joining our webinar today. My name is Alex. I'm from Leader Computers. Just want to firstly thank everyone for attending the webinar. It's always great to have such a large turnout for these things. With us today, we have the team from Ubiquiti. Specifically, we've got Jamie Higley, who is the training director for Ubiquiti. He's going to be taking us through the exciting advancements in Wi-Fi 7. And with that, I'll hand over to Jamie. Thanks, Jamie.
Hey, thank you so much, Alex. Thanks to the leader team for setting up this webinar, and also thank you for everybody participating in the series of webinars we've had over the last few weeks. I believe 2 days ago we had our webinar on routing, switching, cybersecurity, and it sounds like leaders also posted that to their social channels. So if you're looking and didn't get to tune into that webinar earlier, that's already available as well. So the topic for this webinar today is again Wi-Fi 7. Just a few precursors and important tidbits. UniFi has been around for over a decade now. Really, that's what brought UniFi to the market was the need to bring powerful, robust, high-speed, and reliable Wi-Fi with management software on top of it. So our access points in the Wi-Fi 7 arena came to market a little bit earlier this year. I believe we were the first to bring the enterprise grade uh, APs to market back in February with our U7 Pros, and since then we've launched a few others. So let's get into it now. As I mentioned before, UniFi is no longer just a system for managing your Wi-Fi APs. Instead, it's a complete next-gen IT solution with powerful software for managing everything from the routing, firewall, but also physical security on sites, and doing this all um, easily with just tons of AI integrations as well. We'll get into that in just a little bit as well to look at on the Wi-Fi side how we're shaking things up as well. So with UniFi, your journey starts again at the site manager level, unify.ui.com. And Site Manager provides you with global scalability for managing all of your customer sites from a single click centrally from our platform. And here you can see a customer site getting managed with several different applications running on it. Really, this is an important tool that we're going to be continually adding more and more features to in the coming weeks and months. So definitely make sure you guys bookmark this, and I'll share a few other links that you guys can make sure to bookmark going forward. The site manager is also important because you can link all of your different sites here under a single platform. So whether you have the software running on, virtual server, or you're using our powerful cloud gateways or other cloud devices, cloud consoles that are linked to the cloud, such as our cloud keys, definitely take advantage of the site manager. Our cloud gateways are brilliant devices that basically are all-in-one appliances for everything you need on your customer sites. So we're talking advanced Wi-Fi, firewalls, routing, all the applications for physical security, voice over IP. With one of these devices, you can really get everything on your network up and running, and then add a few more devices like switches, APs, and everything is managed securely. All your data is local on your cloud gateway. You can see some hard disk bays as well there for video storage. And the UniFi Site Manager really just exists as a license-free option for you to very easily remotely manage all of your customer sites. And a lot of the Wi-Fi configurations are available directly natively in our mobile apps. I'll go through now and just show you a few of those mobile apps as well. You can download these for free on the iOS store for UniFi Network, as well as for the Protect application, um, UniFi Access as well. And most of the most important configurations and monitoring you can also do from the palm of your hand. We recently added with our VoIP Talk application the ability to have a soft phone. So you can find that in the UniFi identity, as well as our Connect application for managing the smart building and IoT devices, as well as your point of sale and digital signage devices, all managed centrally from the site manager and that cloud gateway serving on site. I mentioned this briefly in our last webinar, but just to touch on it again, it's super important. The identity software is a endpoint solution for managing all of your employees at corporate offices. Um, in these days, a lot of employees are working from home. Sometimes they'll be coming on to the building or site at different hours. And so creating easy permissions across all the UniFi applications, this becomes really the dream for IT managers, UniFi identity. And you can see bundled in there, one-click Wi-Fi, one-click open doors, one-click VPN, all sorts of important features. And this is, again, free, built into the cloud gateways. All right, so a couple of the cloud gateways have, as I mentioned, Wi-Fi 6 integrated in there. That's our dream wall here on the left-hand side. This would be, for a small to medium business, support a high number of clients, multiple gigs of routing with IDS and IPS features. Like I said, these cloud gateways, they're plug and play. They're super easy to get online and set up. And with the Wi-Fi built into a couple of these, including the UX device, you can really get these up in no time and have a hotspot on a customer site. So now getting into the main topic for our webinar, Wi-Fi, I want to take a quick return to the evolution of Wi-Fi and really when Wi-Fi became uh, permeating in the industry, the early days of 802.11a, b, g, it still just wasn't really reliable. You had very low speeds. It was really only when Wi-Fi 4 came out and we saw the first UniFi APs as well that we started to see users pushing uh, speeds close to fast Ethernet. This is around 2009, but again in like the enterprise and in large scale hotspots. Busy public sites, especially high density. Wi-Fi 4 is still lacking a lot of features to overcome some of the issues. And toward the end of the webinar, I'll do an actual kind of training, pull some slides from some of our most popular training courses, including the UniFi wireless admin class to go over, really how does what are the challenges in building Wi-Fi networks? Because in order to get the speeds that are advertised, it's really just a matter of design. Wi-Fi is really not any magical concept. It's just a matter of applying the principles that you learn in these training courses, and you can also leverage some of the AI features that we have in the UniFi network software, which I'll get into a little bit later. But really today where we stand, Wi-Fi 7 is actually kind of ground shaking as far as where it takes us in the Wi-Fi evolution. Compared to Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, we're going to see we're already seeing a lot of major features get introduced and rolled in here that are making this not only a good idea to upgrade, but kind of a requirement not only to future proof, but also just get clients with higher and higher application bandwidth needs served. And as a rule of thumb, Wi-Fi is all about shared airtime. It's not like connecting cables on a switch where everybody has their own switch port, and so you plug in and get a gigabit. That's what you expect, or 10 gigabits. You expect that. With Wi-Fi, it's all about how quickly can you get on the shared channel. You might have 100 users on a single channel in close proximity, and so getting those users on and off becomes very important. And Wi-Fi 7 has a number of hugely important features to allow us to do that more than ever today. So in some ways, Wi-Fi 5, Wi-Fi 6 definitely was bringing us, supercharging some of the features we saw in like Wi-Fi 4. But with Wi-Fi 7, we're going to see a lot of brand new features that are super important. Before we get into those features, though, I just want to quickly recap. The U7 Pro was our first U7 Wi-Fi 7 access point. So when you see this U7 term and U6, it's kind of a easy way to remember Wi-Fi 6 APs, Wi-Fi 7 APs. And this came out, I believe, end of February this year. People were thrilled with this, actually getting multi-gigabit performance on these APs. Soon after, we came out with the U7 Pro Wall, as well as the Pro Max and Outdoor. Um, Main thing to point out about the U7 outdoor, while regulatory domains are still figuring out how 6 gigahertz is going to be used in the outdoor space, these U7 outdoors do support Wi-Fi 7, but it's only going to have the 2.4 and 5 gigahertz bands. But for 6 gigahertz indoor, you're going to see our flagship U7 Pro Max, definitely our go-to recommended AP. And these other APs have an additional 6 gigahertz radio, which is perhaps the most important feature that really enables us to push much higher speeds and also get users on and off the shared channel for maximum airtime efficiency. Here's just a couple of scenarios where you might see some of these Wi-Fi 7 APs being deployed. High density environments. Pretty much for any high density these days, definitely the U7 Pro Max should be one of your first considerations. Another thing to consider for high density is creating controlled coverage areas. So we already have a few Wi-Fi access points that do create in those high density arenas. Our UX, U, our base station AP, and definitely look for some future AP models that will have the ability to control with dedicated antennas that are not just omnidirectional, but really focusing your gain into a particular direction. So you're not only uh, um, creating controlled coverage, but you're not leaking over into neighbor access points and cells. So just to now get into the key features of Wi-Fi 7. As I mentioned, Wi-Fi 7 introduces to us a number of hugely important features. And the first one I should mention is, of course, the 6 gigahertz spectrum. Um, in Toward the end of the 802.11ax standard, we saw 6E APs get rolled out, and a few clients actually made it to the market. It didn't really permeate too much. And so now with Wi-Fi 7, making 6 gigahertz mandatory, you're actually seeing a lot more devices that are supporting 6 gigahertz. And with so much more spectrum available, I'll get into that in the next slide. You're also able to increase your channel width. With Wi-Fi 4, we had up to 40 megahertz. With Wi-Fi 5, 80 megahertz. 160 with Wi-Fi 6, and now up to 320 megahertz. And yeah, it's again dependent on your region. Um, Speaking with the leader team before this webinar, it sounds like Australia is still in consideration of opening up the 6 gigahertz spectrum. Sounds like today you guys have about 500 megahertz available, which is plenty to um, improve the high density networks where you're really reliant on reusing channels in close proximity. A few other key features here, multi-link operation. So this is one way to think of this is like link aggregation, but for Wi-Fi, being able to push multiple streams, but over multiple bands simultaneously. 4096 QAM, so now going up from 1024 to 4096 for increasing the number of bits per symbol. This is definitely important and possible in places where you have very, very low uh, a strong signal to noise ratio. So low noise floor, high strong signal, close to the AP. Definitely is possible, and made even more possible by the fact that 6 gigahertz is, for all intents and purposes, very quiet today as it's a new band. A few other things to point out, OFDMA and multiple resource units. So OFDMA takes the OFDMA transmission mask and kind of breaks up you can think of the channel as having these sub carriers or sub channels divided among the clients that are participating in the Wi-Fi network. So instead of transmitting inefficiently with previous versions, and I believe in Wi-Fi 6, OFDMA was first brought in. But what Wi-Fi 7 does is it now makes it mandatory. So again, just another reason to upgrade to Wi-Fi 7. You're going to be seeing a lot more Wi-Fi 7 devices toward the end of this year, next year as well, as users continue to adopt. MU-MIMO was something we saw first introduced in Wi-Fi 5, but it was only supported on second wave in the downlink direction. With Wi-Fi 6, we started to see uplink and downlink, and now with Wi-Fi 7, we're seeing even more streams. Preamble puncturing, the last key feature here to point out, this is also mandatory, and in scenarios where you would have this narrow band interference that clogs up some of your channel, and it would, in many cases, result in not being able to use most of the wireless channel. With Wi-Fi 7, though, we're able to salvage part of the channel that's not undergoing the interference. So as you can see, Wi-Fi 7, it's got a lot more efficiency. It takes some of the features of Wi-Fi 6 that were optional and therefore, not widespread, not permeated, makes those mandatory. And of course, the 6 gigahertz spectrum, super important. And as you guys begin deploying, definitely get to take advantage of the fact that we, push out firmware updates. So as soon as Australia, supports the entire range of 6 gigahertz channels, we'll also have those available for you, certainly. So as I mentioned, that's still being discussed. When we talk about the 500 megahertz that are available currently, that's going to be the lower band, if I recall correctly. And so yeah, with Wi-Fi 6E, you started to see the introduction of 6 gigahertz, but just compare this side by side with 5 gigahertz for a minute. It's kind of funny to think that we were having to plan high density networks, especially in like outdoor festivals that might have been susceptible to DFS channels. Many of these 5 gigahertz channels compete with neighbor radar deployments. So like military bases, airports, TD, WR, any type of scenario like that really can result in a fraction of the number of channels for 5 gigahertz. So 6 gigahertz, it's a no-brainer. It's not just future proofing, but it's available today. It's available now, and you get up to 59 channels once that full 6 gigahertz band becomes available. 59 channels at 20 megahertz, 29 at 40 megahertz, and again, you can push up to 320 megahertz channels for not high density networks, but local networks that need to get multi-gigabit performance, even at 160 megahertz. Yep, as I mentioned before, this is being considered the upper band for Australia. Few other things to point out. We mentioned that 4096 QAM, what that kind of looks like. You really do need to have strong signal to noise ratio to reach that. But with the 6 gigahertz, you're more likely to reach that just because it's so quiet currently. And when we talk about multi-gigabit performance, the MCS index, as shown here in the background, basically is giving us an estimate of like what our physical data rates are. And with Wi-Fi compared to wired transmissions, you have a lot more overhead. So as a rule of thumb, you can kind of consider a little bit more than half of what the physical rates are shown in these indices. But when you're pushing two spatial streams at 4096 QAM, meaning you're really, really close. Look at this pink area around the AP, and there's virtually no noise. You can get true multi-gigabit performance. As I mentioned, multi-user transmission, OFDMA. This is the AP transmitting to multiple clients simultaneously. And the way it does this is by dividing up. If you look at this this graphic here, in former versions, OFDM, even for small packets like broadcast, it was less efficient because you're using the entire channel in order to send data to just a single client. But with Wi-Fi 6 and now Wi-Fi 7 mandatory, it's saying, all right, let's divide up this channel. Let's make sure we're being as efficient as possible and allocating multiple resource units to clients. BSS coloring is another thing to point out. I believe in 802.11ax, so Wi-Fi 6, we first saw this. And toward the end of the presentation, I'll discuss co-channel interference at greater detail. But co-channel interference, just to summarize, this is, again, coming back to the main premise of Wi-Fi. The channel is shared. So if you have multiple clients across multiple APs that are all on the same channel, that can be very inefficient, especially if they're pretty closely deployed together. You see this especially in high density deployments. And so what happens is you often in prior versions of 802.11 began generating self interference in high density networks. And so what BSS coloring does is it kind of tags these BSSs, so your individual cells become unique. And so if clients in cell 6 um, are transmitting, and clients in the other cell 6 are transmitting, but the threshold for clear channel assessment is not reached, then hey, they'll both be able to transmit simultaneously without having to wait, as we previously discussed. Wi-Fi is a listen first, then talk protocol. All right, and with multi-link operation today, what we're seeing are a couple of devices out there. You can check with manufacturer list to see which client devices support this. In some of our training courses, we also demo the multi-link aggregation feature to show multi-gigabit performance. So kind of your flagship flagship client devices out there. Obviously, one other thing to keep in mind is that using multiple radio bands simultaneously is definitely going to have an impact on battery performance. So that's why you might not see so many of the client devices out there using it. They might prioritize battery life over actual performance. And with channel puncturing here, we just kind of show the resulting channels. Let's say that you're using a 320 megahertz channel or 160 megahertz channel, or something large, and that narrowband interference comes into play. Well, your resulting channel prior to channel puncturing protocols is a much smaller channel, and it's quite inefficient because part of the channel that you could use that's not being disturbed by interference is no longer usable. But with puncturing, we're able to salvage more of those resource units, more of the spectrum, and your result is just higher performance, higher throughput. All right, so moving away from the features now, those are the main ones to discuss, but we have some killer apps that you guys should all be taking advantage of if you're not already. WiFiman is one of our most popular mobile apps out on the iOS and Android devices. You can look on the stores for those today. And you can see at the bottom a number of the features, so being able to test your Wi-Fi speed, get a good look at the speed test out to the internet, signals, start to build these heat maps as you walk around your coverage area. When you're planning, it's often important to use tools, but we all know that going out and doing actual site surveys is going to give you a better estimate of what clients are going to run into before you roll it out live. So this is a hugely important tool, packed with a lot of things. It's even got Bluetooth scanning built in, Wi-Fi scanning, as well as teleport for doing VPN with one click. The WiFiman is also available for desktop as well. You can download that for your desktop devices, and definitely take advantage of the spectrum analysis tools we build into the UniFi network software. So all of our UniFi access points have what's called RF environment scanning. This is under the insights section under the individual APs, and you can get a good indication of how much of the channel is actually being utilized, what the interference levels are, and gathering that info, you can also start to build your own channel plans. Uh, One really crucial feature on the U7 Pro Max, compared to those other UAPs, which do have to take down the radio in order to run those special channel RF environment scans, as I showed in the previous slide here, because they only have a single radio that's dedicated to either um, serving the service set, your client devices, or running these spectrum analysis tools. Uh, by contrast, the U7 Pro Max has a dedicated uh, um, radio that can handle things like real-time spectral analysis without dropping client connections. So I'll do a quick demo on this a little bit later, but just want to bring that to your attention. This is extremely important for being able to, you know, in real time see, hey, what's that cause of interference, and analyze the actual spectral patterns without having to go into like packet captures and elusively understand what's going on. It just gives you another tool in your tool belt at the physical level. And you can see we break it up in like a waveform and a waterfall view. All right, a couple of other software features. Our developers have been working very hard. They're listening to you guys over on the community. And yeah, one really important part is the coverage. So when you have all of your APs selected under the radios tab, you can get a really quick insight into the overall picture and start to make some quick on-the-fly changes. So, areas of your network where uh, see a general trend in lower signal. Obviously, it's probably a better idea to either increase the transmit power level, but often that's just not sufficient because you have what's known as a uh, AP client mismatch or signal mismatch, where these AP devices are very high powered devices, and sometimes these client devices, even especially like IoT devices, might just be transmitting at a fraction of the power levels of your APs, and so you have to be careful not just to immediately increase or transmit it high, but also kind of come here and figure out, okay, maybe I need to throw up a couple more APs to get closer to my clients. Maybe I need to introduce some dedicated antennas for some of our APs that support external antennas as well to create those strong coverage areas. But again, this is a super important tool. You can organize your overview and see clients in real time, especially. Another way to troubleshoot is through the connectivity tab. This is going to present to you the most common connectivity issues that you see with Wi-Fi, and it's not always Wi-Fi related. Sometimes it can be caused, by DNS service failure, DHCP issues, and so getting a quick insight into that at the connectivity tab can really make your life a lot easier, knowing where the failures are happening, uh, and troubleshooting that more efficiently. As I mentioned, packet captures is something we recently added. We'll also be developing this a little bit more, so keep an eye out for this in the coming versions as well. More integration, being able to do more things with the information presented. Um, but yeah, this is definitely something for the Wi-Fi guys who are interested in seeing at the frame level, kind of the Wireshark level, what kind of uh, wireless activity is actually happening on my network. All right, and one more important software application I want to look into before I do some demos is the Ubiquiti Portal app. So this is one of our most popular apps, and I say that not because it's widely downloaded, because it's actually a pretty recent mobile app that we launched, but because when I share this with people, they go crazy for it. There's so many things bundled in here. The main one I'm showing on this slide is the Wi-Fi calculator. So I'll demo this in just a minute, but you can do a lot more things on this Ubiquiti Portal app, including the console calculator. It has native support for the Ubiquiti community, so you can stay on top of new releases, see all the features as they get added in on the software side, also on the hardware side for your Wi-Fi 7 APs. So yeah, a few more things I want to just touch on with like training here. The types of interference. So there's generally speaking two types of interference in wireless networks. And the first is what's called co-channel interference. I alluded to that earlier when you have multiple APs operating in close proximity using the same channel. So let's say I'm using two APs on channel one. Well, they can only talk on only one device can use the wireless channel at a time. Wi-Fi again, it operates on the premise of listen first, then talk. If two devices try to talk at the same time, which often happens and results in what's called a collision, then you start to see degraded performance. So that's a one type of interference. The other type of interference is called uh, adjacent channel interference, and that, as it sounds, is when you have uh, co-located APs or devices that are operating in close proximity, but also using neighbor channels. So as you add more and more devices, especially on the 2.4 gigahertz, it's often common for you to open up an app like WiFiman to do some Wi-Fi surveys, and you start to see, devices on channel 2, channel 5, channel 9, and so it's kind of like the wild, wild west in metro areas, and that's why we typically only recommend 2.4 gigahertz using 20 megahertz because you minimize the number of adjacent the you minimize the amount of adjacent channel interference that you see, all this red overlap between neighbor channels 1, 6, 9, 1 plus 5 from 40 megahertz channel. Um, so yeah, this is a pretty important thing to avoid. Um, and as long as you're using auto channels with UniFi, it's typically going to choose 1, 6, and 7. But in especially like high density networks, the more and more channels you have side by side, the higher your adjacent channel background results, and that will reduce your signal noise ratio. So 6 gigahertz again gives you up to 59 of those 20 megahertz channels, and I'll hop into that in just a minute. Um, so with power spectral density, this is giving us a quick insight into what a Wi-Fi transmission mask looks like. Um, so you have your channel width here in the center, but toward the ends of the channel, these radios, they're nonlinear devices. So what results is you end up having this undesired transmit power that results in that adjacent channel interference I was discussing before. So that's why, again, it becomes very important to try to choose with 5 gigahertz and 6 gigahertz channels that are as far away as possible. Our Next AI Wi-Fi software is good for optimizing here, but in generally speaking, um, with high density deployments, you often have to come up with a good channel plan and avoid those issues. The last thing I want to point out is how coverage and channel width are related. The smaller your channel width, and this touches on the power spectral density slide I was discussing here, uh, the smaller your channel width, the greater your density of power, and so that results in better coverage when you're using smaller channels. Often when I'm at like conferences or I'm at trainings and people, point out to me, hey, I'm having issues with my signals. I'm using the Wi-Fi 7 devices. And so immediately that calls to attention the fact that maybe they're using, larger channel widths. And I bring up with them, hey, if you're going to use those larger channel widths, make sure that you're closer to the access point. So in high density deployments where your main concern is, performance over high throughput applications, you do typically want to look at like 20 and 40 megahertz channels, especially because coverage and roaming can become a requirement. So guys that move away or clients that move away from the AP are definitely going to experience faster roaming or propensity to roam faster if you're not careful. All right, last slide to bring up before I do demos. This is our essential UI resources slide where we point out to you just the most important applications that are available when you're planning your networks or you're just educating yourself on all the different features. You know, we're an R&D company first that prioritizes bringing you the best hardware and software features in the UniFi platform. And so as long as you guys are subscribed to our newsletter, our community, you'll be sure to find out about the latest solutions as soon as we have those available, be it new Wi-Fi 7 APs or cloud gateways. We'll definitely have more stuff for you guys in the pipeline this year. So definitely stay tuned. And yeah, before we go into QA, just want to jump quickly into Site Manager. Again, this is great for managing your customer sites. Here I can quickly see all the different applications that I'm running on my uh, cloud gateway. I'll click here on the network application, and it will give me just some dashboard, high-level insights into traffic and connectivity at my customer site. Here under the Radios tab, I can immediately start looking into the insights for individual APs or all the performance across the entire network. You can see here, this is a pretty small site, but I can get a kind of a scatter plot look at all the different devices that are on my network. And so once you get past this minus 70 dBm signal, again, minus 70, that's not a negative number. This is a threshold that represents real world values, set minus 70 dBm, decibels mapped to milliwatts. Okay, so 0.0000, a tiny fraction of milliwatts that's reaching my client devices. So once you get into like minus 80, minus 85, that's definitely when devices start to encounter signal to noise ratio that's super low, and they start to have transmit problems and have retries. So that's when they start to roam. So again, we try to simplify things here on this dashboard and give you a quick performance view. So if you start to see a lot of clients in this area, you'll probably want to consider throwing up an extra AP. And when you start throwing up new APs, you might start seeing new issues with clients joining the network. So we try to summarize the most common issues that you might be running into. Looks like on this network, everything's performing pretty good. On the radios tab, we can see a few of our APs as they're performing on 2.4, 5, 6 gigahertz. This will give you some good insight. The environment tab is also important for looking at kind of site surveys, understanding what other competing Wi-Fi networks are in range, being able to sort these by signal, which channels are most congested, as well as other vendors. Some vendors can have certain behavior that can affect the network. So let's come to a particular U7 Pro Max. I'm going to open up the environment tab here, and under the spectrum tab, you can see it's analyzing constantly in real time with these dedicated radios that the U7 Pro Max has, 2.4, 5 gigahertz, as well as 6 gigahertz. And 6 gigahertz, I'll quickly show you, it's going to be very quiet. Not too many other devices. Oh, it looks like I have another. Yep, here it's running on this tab right now. And you can see in real time, these channels are actually moving to give you a clear insight into real time, what's going on at the physical layer. And of course, 6 gigahertz, so many more channels available. Uh, whether you're running 20 megahertz, 40, 80, definitely check out these U7s. Definitely our best performing devices. The U7 Pro Max, our flagship device. It has all the bells and whistles. And yeah, I think with that, we'll go ahead and move into one more thing, the Wi-Fi calculator, as I mentioned earlier. Wi-Fi.ui.com is where you guys can find this, or it's also bundled in the Ubiquiti portal app. And we actually use this software in the UniFi training courses to teach some of the common misconceptions about Wi-Fi, also in general how Wi-Fi works. But just to start, this is a great calculator or simulator that allows you to get not only coverage accurately estimated based on the unique 6 gigahertz antennas, 5 gigahertz antenna patterns, 2.4 gigahertz antenna patterns, but also, like I said, it'll give you insight into how your coverage will change depending on your channel width that you've got selected. Again, 20, 40, 80, 160, because of the power spectral density, it's going to affect your coverage. So you have to be very careful about these things. And we also give you this client picker tool to let you simulate what your performance will be depending on whether you have a Wi-Fi 6 or a Wi-Fi 6E or a Wi-Fi, even a Wi-Fi 4 device, what kind of speeds you would see depending on where you are uh, relative to the coverage area of the AP. So yeah, whether you mount on the wall or the ceiling, we typically recommend with these circular flagship APs that you install these on the ceiling because of the kind of donut shape that they have. So if you are going to do a wall mount, we typically recommend actually using the U7 Pro walls. You can see the coverage is going to give you a much better desirable coverage. It's intended for the wall as well. But again, that Pro 7 Max, you're going to see the highest possible speeds. To get that 6 gigahertz, you have to have the Wi-Fi 6 E or Wi-Fi 7 devices. And we'll be seeing quite a few more of those over the next few months, years. And these are definitely devices that will future-proof you for years to come. All right, and with that, I'd like to thank you guys for participating and open it up to Q&A. So thank you, Alex.